You know, I've been all over the country and tried hard to make this seem complicated, but I just can't. This is our process. This is a piece of polymer. This particular piece is fluoroelastomer, but it can be just about any polymer. The people that do the mixing take this and mix in dry powders which look like this to form the rubber compound. The rubber compound can be pretty expensive. For the most expensive ones, it can be up around $15 a pound. For some of the less expensive, maybe $2. Then, the people that mold the parts put the compound into a hot mold, and the parts come out looking like this. But in addition to the parts, there's also some byproduct that's produced at exactly the same time. Now this is exactly the same rubber that went into the part, and the properties are just as good, but it can't be reused in this form. So at the end of the day, you're left with some parts and a pile of byproduct, and it costs you $15. What we do at FRS is help the molders capture this byproduct and turn it into a fine powder which looks like this. We take the powder and mix it into the polymer, along with the rest of the normal dry ingredients, but instead of using this much polymer, now you only have to use this much. You add a little less dry ingredients and it forms exactly the same kind of compound, except in this case, instead of costing $15 a pound, now it only costs $13. The compound goes into a mold and turns into parts which are exactly like the parts that were produced before. We've done a lot of technical work to confirm that the parts produced this way have equal or better performance. So by this time we have the parts, but instead of the pile of byproduct, we have $2, which we can put in our pocket. So you see, it's actually pretty simple. You can have the parts plus a pile of byproduct, or you can have the parts plus $2. Now multiply everything I said by 1,000,000, because a lot of the companies that are in this business producing those kind of quantities. You can see the enormous potential from an economic and environmental standpoint. For any additional questions, visit us at www.fluoroelastomerrecycling.com, and we're ready to start when you are.